Hey everybody, thank you so much for joining. We're here today in the MetaX offices. Got the team with MetaX here. We've all been working hard on this presentation. And after the webinar, everyone's going to get a copy of the deck, copy of this video, and in the deck, there's a bunch of URLs and links. So as developers, you can dig into some of the resources we found. And I also just wanted to flag that we have had someone at Google take a look at this presentation to try and flag any inconsistencies, anything that was wrong, made a few minor changes. This presentation is obviously not like greenlit by Google or anything, and I'll probably say some off-message things, but it is as accurate as we could make it. And as people flag any inconsistencies or new strategies to mitigate the SameSite changes, we're going to update everyone via email who registered for this webinar. And we also expect to maybe do a couple more of these webinars and additional training resources for the public and for our clients in the lead up to the SameSite changes. So just going to jump right in. And the high level is, are you ready for the incrementally better cookies from Google Chrome? And this incrementally better cookies is a framing that Google has put together. I believe that it's actually a significant change to cookies. And so we are going to basically walk through some of the things that basically you should be aware of and some of the problems that can happen. So first off, what can be blocked by these SameSite changes? So everyone sort of knows that cookies are the primary thing that are being blocked. But in data supply, cookie values are being sent not only as cookies, and everyone who's in ad ops here knows about this, the triangle syncs, the various types of sharing of strings. Because of that, when we audit websites, we are not only finding the cookies being stripped, massive amounts of cookies, but when those values are tied into other types of syncs, we're finding empty parameters, broken URLs, and this ends up impacting basically any system that uses JavaScript. Any session-based systems, authentication systems, your analytics and advertising pixels, checkout flows, you name it. And basically, if it's an iframe, and particularly if it's an iframe that is trying to do any sort of session authentication, you're going to have a lot of trouble. So we're going to kind of keep on moving here. The high-level thing that everyone should sort of be aware of is that in March 2019, Google ran some numbers through their telemetry, got some high-level details that they've put out publicly, and have continued to use HTTP archive and some resources to figure out how prepared everyone is. No one is prepared. So March 2019, 9% of global cookies had the secure flag. That basically means 91% of people, if the change happened in March 2019, would have lost access to cookie data. 91% of the global data gone. 84% of the cookies that they tracked had no flags at all. These numbers have been going down because some of it is based on very large networks, but the most recent numbers were only about 70%. And that was also only with some of the biggest websites. So in our analysis, it's much more like that 84-91. Almost no one is ready. The other really sort of scary thing that everyone should be aware of, every cookie that you are setting today without the SameSite none plus secure flag, gone in February. That data is not there. You have to rewrite the cookie with the new flags. You can't read that data. So because of that, Rubicon, one of the few companies that got their stuff together early, add this. There's only a few ad tech companies that probably have Black Friday, Cyber Monday data. So heads up, every day you don't get that flags flipped, it's less data come February. The other really important piece that we've been seeing in our audits are fallback URLs or rollbacks, the process where you basically don't hard code HTTP, HTTPS. And this is most common in big JavaScript files, big arrays, where you piggyback your JavaScript files and you want them to be able to load in HTTP or HTTPS. The problem is that falls back to insecure, and after the SameSite updates, your pixels will break. And so if you're in a piggybacking chain and someone before you in the chain is insecure, your flags get insecure flipped as well. This creates some piggybacking scenarios where, for instance, add this with pixels that are working and have flipped their flags. It's piggybacked into a lot of websites via connections that don't break, or they break, or they have problems. And so the backend pixel doesn't fire. We're seeing that a lot. And it's something that basically, if you do JavaScript piggybacking or you rely on it for revenue, you must audit how each of those pixels are firing and how it will impact your fill rates. We have some stats here. There's links in the presentation that I'll send around, but largely these numbers should scare everyone. And these are very common, or what we're seeing as we audit enterprise sites. No one being ready, just a tiny amount of cookies slipping through. And we're less than 2 months away now. So if you're on this call and you don't have extreme confidence that you've audited every cookie in your environment, you have dozens of threads with your partners asking when they're updating SameSite Secure, and if you haven't updated your own, you're in the same bucket, and it's going to be a lot of work for the next 2 months. We just wanted to also clarify again that we're 2 decades in, and part of this presentation is going to have some stuff on PHP, some legacy code, and if you look at what resources Google is providing, a lot of it is legacy code, because some of the more modern stacks may be in better shape sometimes, but this is from the 90s. So enterprise companies that have been around for a while, your problems have been piling up. And there's also almost no one who has a big enterprise who's vetted the costs. Microsoft was basically one of the first people on this. They're chiming in with the Safari threads with Google. They're have their team members going into various communities to talk about it, and it costs Microsoft $10 to $50 million to do some of their updates. And we have links in here for some of the work that they've released. This is a massively expensive Y2K-like problem. If the entire world depends on digital cookies and 91% of them are barely there, everyone needs to be spending real money here. Here's the other scary part. This rollout would have already happened had it not been for a minor Safari bug and the Microsoft team asking for a little more time. And so the other piece that should scare folks is, if you aren't ready now, this was actually going to go in place August 31st. There were multiple deadlines where they pushed it back. And the Safari bug also creates an issue where you have to do user agent sniffing. So we've got a couple slides here in the back on that as well, where the problems that kept this from already being live, thank God, are also kind of confusing. But basically, Safari iOS 12 has a bug where the current SameSite equals none strict, which is supposed to allow data to cross domains, that flag in iOS breaks it. It actually does the opposite. And so they were trying to figure out how to time certain things. Long story short, iOS 12 never coming. So everyone, if you have a large enterprise and you want to deliver cookies in iOS 12, you're going to have to do user agent sniffing and basically do a double cookie scenario where you serve some cookie flags to your known Chrome users and some cookie flags to this environment to be able to send their data. There's also some links in here to these discussions. So you'll see these are like Google employees and whatnot. I would strongly encourage anyone who is going through this user agent sniffing process where you have millions of visitors and you need to figure out how to sort of segment this and get their cookies delivering, join these conversations. They definitely are complicated. So we're not going to get too into the weeds here. This is the Microsoft update that basically they have for ASP.NET and their auth systems. This is still being deployed in live systems, and there are lots of threads with people starting this process, and you can see it was just released in October. So even Microsoft, if they hadn't have pushed back and helped to get everyone sort of understand that these needed a little more time, we wouldn't even have had this update. So the other issue is actual testing. So I know a lot of people are on this call going, hey, we use HTTP archive, we use Web X-ray. What does the MetaX team do that's special? Well, the reality is we do local auditing where we're going into user experiences, sessions with real people, tracking how auth systems break, how real things break. And there are tools like Selenium that can facilitate some types of this automated testing. The problem is tools like Selenium, you can't even flip the flags. So this bug was open November 19th, and the comment was like, yeah, this would be great if someone else would help to develop this. As a reminder, most of the Selenium team has been hired by Google, and so it's kind of ironic that they're going back to this open source asking for this. But as it stands right now, you can't even flip the flags in Selenium. So you need to basically start pulling up some user experience tests by manually doing the Chrome flags. Some people also potentially are familiar with the call center disaster that happened a couple weeks ago, where Chrome had some flags that were used in very niche situations. And when they turned those flags on publicly, a bunch of call centers went down. You can read the news articles about it, but basically Chrome learned from it, and they do have this escape hatch for internal systems that could be negatively impacted by the SameSite cookie change. And there's some notes in this slide as well, but in short, you probably shouldn't take this escape hatch unless you already have your entire business working in this sort of enterprise Chrome managed environment. Otherwise, it's just extra development work, but that is going to be available for folks. The other piece that I know everyone is sort of just scratching their head on is, how do you remember these changes? How do you train your developers? And how do you do these audits? And so we've been trying to put together some quick resources here that you can also share. And this is just a clean example of the way that this breaks. Some of the cookies they'll pass, and you may see them in network requests, but then they won't be sent back. They won't be saved. So an auditing of what data is sent to you without an understanding of, did that cookie get saved, and in future requests, does it get sent back? That nuance is sort of where this breaks down with trying to automate your testing. And it's the piece that I really want to make sure everyone understands. This is how it breaks. Look for this in your testing, and that will prove that you're finding the flaws. The big piece that we as a team have been discussing a bunch, and I think a lot of folks are trying to figure out how to work through this, are, how do you remember these protections? So we basically don't love the same site equals none, same site equals strict. It needs a little extra nuance. So we mentally sort of add the word protections so that you can kind of explain it in a normal way. We say same site protections, none or off. Data can flow across the domains because the same site protections aren't there. Strict protections can't flow. And then lax, which is the new default. And that word is confusing because the new default stops data. And so we basically were like, lax is such a bad word. So we literally are like, laxatives is the only word. Same site protections equals laxatives helping to shit out invalid cross-domain data transfer attempts. That's crass, ridiculous, but that word is tough to remember. So if anyone else can come up with a better way to remember that the word lax means to get rid of and to reject data, please let us know. Otherwise, this is basically the cookie flag naming convention that everyone has to start to get familiar with. One of the most scary things, and the reason why so few cookies have the secure flag, is a logic flaw that most people don't realize. Just because you serve your cookies or your JavaScript over HTTPS via an SSL, it doesn't add the secure flag. You have to actually code the secure flag into your cookies. And so many people are, when we are doing these audits, we see they're flipping to SSLs, doing some of the things, but they don't have that secure flag. Don't make that mistake. Very important. PHP is one of the trickiest ones to debug, and we have some resources here. Google helped to give a little more nuance here, and they also have some resources on their GitHub page that we've linked to. But PHP's been around longer than SameSite cookies, and that leads to interesting problems. So I'm not going to get into all this, but if you're a PHP developer or have PHP in your stack, you really need some people to dig into these details. The other piece is, eventually, Chrome is going to require all cookies to be marked secure. That's not what happens in February, but if your team is doing this process of manually writing that secure flag because you probably didn't have it previously, just add it on every cookie, not just the cross-trust domain cookies. There's no reason to not put this flag in. It's been a low-hanging fruit for years, and eventually, if you don't make this change, even your first-party cookies are going to be blocked. Secure is coming everywhere. Start this now. Don't be in another situation where you have 2 months and you're about to lose a bunch of data. Another thing, it's coming to Android too. That's the other thing. If you're not preparing for browser APIs driving all data flow across all devices, then you're not preparing for where data is going now. And Android's web view is a headless Chrome window. But what's important is it currently does its own little SDK shenanigans. It's wild data flow out there. And this is how it's going to get cleaned up, one step at a time. And it's going to start with same-site restrictions. Then it's going to shift another way. And everyone needs to sort of start to get ahead of the game so that we're not having to do this weeks and months before stuff implodes in our face. Here's the other problem that some of y'all are going to face. There are not code support repos for everyone's modern stacks. You can see what Google has. We have a couple of the resources in this presentation, and you may be able to find some over the next couple of weeks and months. But if you don't see code support for the code language that you use or your partners use, you probably need to hire someone to start testing that and writing that code now. And I would recommend reaching out to the Google team. They're super helpful for that testing process. The other important thing is every network request sends cookies. Any modern website, anything that's normal, you'll be setting cookies with requests and sending cookies. And so Nick on our team and other team members who have been looking at the auditing data, you almost think you have problems in your architecture with how much cookie loss is occurring after the same site flags are flipped. And Google's data shows you how much data loss is occurring. We have seen this on our end, and some of the audits that we've been doing for clients and this niche, it should scare a lot of people who use fill and partner fill, and you should start to basically see how many cookies you send with every request. It should alarm you a little bit. The other thing, and I've mentioned this a couple times, but if you don't have your same site secure flags now, that cookie data is gone. There's no like backup plan. People are already duplicating their cookie values, because if you have the legacy cookies with the multi-year expirations, which are going to be worthless after February, and then you also have the new cookies with the new flags, you need to start sending both of them. And then you also may have the user agent cookies to get the iOS 12 and whatnot and other devices firing. There's a lot of work ahead. And we're seeing not only just sort of the 2x cookie, Rubicon, I suggest other folks in this industry look what they're doing. 2 to 5x their cookies. They're doing something that many folks are not.
So Zach, we have a question that does overlap a lot with this last slide. If you want to take a look real quick.
Yeah, definitely. That is correct. Great question. So there's basically a question of if you if you have cookies and you change the flags, they will stay. So great point. And that's actually a nuanced discussion. There's a lot of people having that of saying, should I flip my flags or should I create new cookies and just duplicate them? And it has to do with like how big your request headers are. There's a lot of factors in this. I think more people are doing the duplicated cookie route than actually flipping current cookies. And that is an interesting discussion. So I'd love to have that in further conversations. So great question. The other sort of piece that is kind of scary for folks are legacy entities. So I'm using the New York Times as an example because they have the nyt.com domain, and there's legacy pages where they're interwoven. Those are two separate domains. It doesn't matter that they're owned by the same legal entity. That's this, and so they have basically data problems. It breaks. They have to comply with SameSite restrictions, and a lot of folks have that, where you may own multiple domains, or you may be using a CDN subdomain or something where it's a core part of your infrastructure, but now it's actually a cross domain, and you have to acknowledge that you've built that. So the thing that we've been seeing just break in horrible ways for certain marketplaces, e-commerce companies, for instance, if you have a marketplace with 3 to 5 domains and you have sort of a community ecosystem where maybe an app is piped into an admin panel via iframes, those iframes, if they're doing SURSIF checks, if they're doing session-based authentication, they break. Iframes with a post request, the cookies do not flow through that. They break after these changes. And right now, there's a 2-minute delay. So Google basically saw that this was a massive problem in their testing. Microsoft, I believe, flagged this. And they said, we need a 2-minute window where if we send these post requests with the cookies in them, if the response comes back with a certain period and with certain other restrictions in place, it will be included. This little loophole is going to be removed in February at an undetermined date, and no one should rely on this. So why this is very scary is if you flip on your Chrome flags and then go testing through your sites, this will not be flagged because it currently has the loophole built into it. So you need to actually find iframes that are doing this post strategy and help to basically change that, and clock's ticking. So good luck with that. The testing process, I flagged how this is challenging to test. And we're going to go through how we test here and talk with folks more and be able to offer the services. But here's one example of kind of a nightmare scenario where this was turned on for 20 hours and 106 unique user agents flew through the test, AKA lots of user agent sniffing and potentially unique cookies based on the size of the audience for some of these unique user agents. And the SameSite cookies changes basically require everyone to suddenly become an expert on user agent sniffing if you want 100% cookie coverage. Straight up, check it, take it to the bank. So this slide, there's a link in here to this gentleman's blog post, I believe. It's one of the best SameSite tests I've seen, where this person is basically testing an authentication system, and they have really great notes. And the scary part, there's a field that's kind of hidden here. It says expected result. And throughout the test, there's a bunch of them that say no. And someone like this that's like obviously very organized and is planning these tests and is going, I think this is how this should work. And they're actually putting hypotheses and then they weren't aligning. My mind basically blew. I saw that and I was like, oh man, everyone needs to review this. strongly recommend, if you are trying to debug auth systems, build a flow like this. Write down your expectations, write if it's working, and document the results. It is complicated and nuanced and doesn't always work the way you think it should. And this basically, I'm going to kind of blow through some of these, but basically, if you have architecture with lots of domains, even if they're domains you own, you need to become an expert on SameSite. So an entity like Shopify with their core shopify.com, if you sign up for a Shopify store, you get a subdomain on the myshopify.com domain. And then if you are in their apps marketplace, your code is hosted on apps.shopify.com. And there's a series of, they also use iframes that point to unique app domains. And in that flow, some of those apps have social login tools that have shared tokens for user authentication. There's ecosystems like this. And I know that many enterprise companies have Shopify stores and various little monetization engines like this. They need to be vetted and they need to be investigated because there are problems in these types of flows. We have done quite a bit of testing on these e-com platforms, and the login flows are pretty scary. So this is a video just really quickly of a Facebook login flow on a Magento e-commerce website. So this is Sun and Ski Sports, a pretty major e-com, and they have you should look at their source code on their page. It's very unique how they've integrated Magento and these third-party apps, but it's also not uncommon. And what you're going to see is trying to log in with Facebook, you're not going to be able to see the pop-up windows, but the domain is shop.pe. There's basically an extra domain in the auth, and the SURSIF checks are failing. So there's basically an iframe failure, and the same sort of thing can happen in a lot of weird ecosystems where you have multiple domains or any quickie widgets or iframe tools, they can break. Let's go to the next slide. The other part that is kind of important is with these multiple domains, you're going to always want to be aware of which subdomains can be used by other people in the public. And there's basically a first party set. There's a couple slides here. I'm going to get into more details, but Facebook, for instance, has their Facebook instant games, and everyone who uses an instant game gets resources on apps.fbsbx.com. Kind of odd, but there are domains and subdomains like this that you should be aware of as having cross-site implications. And as many people have been trying to figure out, can you set long expiration cookies? Nope, it doesn't work. They're not accessible after the change. The user agent sniffing. You'll find a lot of people in threads kind of coming to the realization of, is this actually what I need to do to target incompatible clients? Yes, it is, unfortunately. Or fortunately, come up with the next user agent software as a service company. There could be easier ways to do it, so please help everyone. The Facebook subdomain, it's related to first-party data sets and this public suffix list, and I don't want to get it too confused because they don't really impact SameSite too much. But these are basically lists where there's CNAME hacks. There's all these different hacks that we know of in ad tech that are being identified, being put into schemas where at some point, that's not going to be a hack anymore. The understanding that certain subdomains are actually connected to other entities, the actual flow is not hidden. And so I just wanted to kind of put this here for folks to dig into the public suffix prefix list, understand the concept of like sometimes subdomains have cross-site implications. Firebase is a good example. If you have multiple Firebase projects, those are on unique URLs and have the cross-site implications. Be aware that those hacks, these things are being identified and being removed at the browser level. The impacts of bandwidth are super interesting. We believe that in a few months after the same site, bandwidth is going to be dropping significantly. All signs kind of point to that. In the lead up to this, many people are doing this double cookie solution, and you're actually seeing more bandwidth. You're seeing request headers being capped out, people having to see a lot of interesting sort of factors with how many cookies to try and stuff. This is going to be something to keep an eye on. Your bandwidth is going to change. There are also some kind of fun hacks that people are suggesting and could work in some ways, like forcing secure. So you can throw this field into your HTML, and it will force SSL along your chains and break things. So this is the kind of thing that you would probably want to test heavily on a dev site, but it's also the kind of thing that after February 4th, there's not a whole lot of problem with throwing this in there because everyone needed to be upgraded anyways. The sort of one piece I just wanted to flag is like part of this February, why on February 5th, all the old cookies stopped working, all those like the cliff, we fall off a cliff. It's because no one has been doing the correct behaviors for 22 years. So Google and anyone who's been looking at this, basically, it's the default now. No, the developers were not making the secure choice. They were not doing these flags. It has to be made a default to force people to do it. The pressure you're feeling to do this and the data loss you're going to have across your supply chain, it's happening just because no one is doing the defaults. There's this slide here, and I'm only putting this here. It does not relate to SameSite, but cookie flags. There's a cookie flag HTTP only. Some of us here got a little confused about its reference to HTTP or HTTPS. That's not what it means. It just means whether or not it can be accessible via JavaScript. And the HTTP only flag cannot be accessed via JavaScript. It's only sent via the server responses. And this slide is a little confusing for some folks, but we wanted to put this as a resource. Just kind of getting back to it, everything must be moved to SSL. If you haven't done it, you're dead. You have data loss. You need to also just start flipping all your cookie flags. We have been sort of talking internally about some of these dependency chains, the piggybackings. And quite honestly, we believe since almost no one in ad tech and publisher world has been doing this, and we need to debate it, and this flipping has to happen before February 4th, we should almost pick a date in January or December where it's kind of like a big global LAN party where everyone is flipping SSLs and helping people with those problems. I'm going to leave that back to y'all in the community that have more influence and resources, but it does help to do this in a coordinated fashion, and this is kind of confusing and would be helpful with your 30 or 40 partners coordinating it and helping some of the other developers who may have questions. The other sort of pieces of this presentation that we're just going to kind of fly through are all of these changes are leading to browser APIs, HTTP tokens, and the future of data transfer. So this is not some like just do it because you have to. You need to do this because you have to and start to see where things are headed and immediately start plowing your R&D into it. And the browsers are going to block all JavaScript server data transfer before you know it. And it will have to flow through browser APIs. If you've looked at Safari's browser APIs and said, we don't have enough Safari users, we're not going to build towards that, wrong, wrong, wrong. Chrome is modeling them. Everyone is going to model them. Learn from what Safari is doing. Their referral sandboxes, all the stuff that requires new architecture for your optimizations, you have to learn it. The HTTP state tokens can only be transferred over SSL, secure requests. So the movement from cookies to these state tokens requires everything on the internet being a secure connection. And in March, so a month after the SameSite changes, Google is depreciating HTTP 1 and HTTP 1.1. This is the depreciation. We're in it. 2020, by the end of 2020, we're going to be closer to state tokens than we are to all the cookies we've been using for the last 22 years, like that. The details here, there's links as well. I'm going to blow through it because it's really, really detailed. The other part is first-party data sets. So that lax flag is confusing, and many people know it's confusing. And it's also not nuanced enough, where we spoke about subdomains. You can own multiple domains, NewYorkTimes.com, NYT.com. That's where a first-party data set comes in for auth systems and these situations where you own multiple domains. We would strongly encourage reading these and thinking about them in terms of it's not for February, but this is how the browser APIs will evolve. And the SameSite lax, breaking all data, is not how that will always be. SameSite lax is going to get nuance, and eventually you will be able to use those in the browser APIs, and it will be secure and safe using first-party data sets and other public resources. The sort of aspects of this are cross-org. So the simplest way to think about it is we're dealing with cross-site implications and cross-domain implications. The future is better cross-org data flow. Cookies, headers, that's the future. And reading through this, we're not going to basically get into that because I wanted to basically make sure we had any time for questions. And if we don't, I'm going to plow into the next section and just sort of assume that the questions will come to our email and whatnot. So we've got a couple videos in here as well. I'm not going to basically show this video. Nick is going to put out a couple more videos throughout the weeks and months. But we basically are putting these videos together so that your developers can see the nuance of breaking, where it's confusing that certain flags break and other flags don't. So instead of having to have every developer go out and spin up multiple domains and these tests, we're basically trying to create videos and these simple walkthroughs of the common scenarios just so you can get quick reminders about the logic. So after everyone watches this video, or if you have questions afterwards, ping us about scenarios. And Nick, our genius over here with all this architecture, is going to help to craft these so that people can kind of see the breaking. And as we've sort of mentioned that, like, we're 22 years into this. It's because the original cookie protocols didn't have cross-domain sharing. It was implemented in the late 90s, and it's been done with the hope that those cookie flags would evolve it to a place where it's okay and secure, which never happened. So that's sort of why all those flags where the secure flag was adopted with 9%, it's basically being put to bed. It's going to be ramped up, and then eventually cookies are going to be replaced by state tokens. So what you're seeing is the transition of insecure cookies to secure cookies and secure requests, and then that will shift eventually to state tokens further down the line. And it looks like we may have another question. So basically using state tokens for persistent IDs. So that's exactly the concern. So there's something called a privacy budget. So I'm going to jump right into the next piece. So an HTTP state token, if it's transferred through a browser API, can basically filter out certain shared strings and known things like lat long, IP addresses. The browser API can provide that extra layer of filtering of those tokens. There's a couple really good blog posts that sort of take the SameSite first party and the state tokens and give you that forward-looking proposal. So I just want to make sure that everyone knows that, like, this gentleman that runs this blog here, he has quite a few blog posts, and they're quite good on helping to see the future. So I would strongly encourage pulling up a couple of them. And Google over the last 2-3 weeks has been quietly, very, very, very quietly, I'm the only one who's forked about half of these, have released under their own employees' accounts these proposals that will be where browser APIs go. So if If you're confused about how we're less than 2 months before a massive change, it was debated in these forums like GitHub posts like this. And Pigeon is basically differential privacy. I'm not going to get into these because they're quite long and they're for future webinars you may do. But sharding web identity basically is the answer to part of that question with the HTTP tokens. And as you read these proposals, you'll kind of see where they expect HTTP tokens to have this browser API filter layer. And my favorite is the willful IP blindness. So this is brilliant, and it's exactly how a privacy budget is going to work. So if you don't have teams that are strategizing your 63-bit privacy budgets, get going. But basically, an IP address is such strong PII that if you try and send an IP address in the future browser API data syncs, your privacy budget will be reduced to 0 and that data won't send. So the best way to think about it is people who try and do shared strings or non-consentful data, stuff like willful IP blindness, when the browser API catches it, it will just start holding it, bucketing it, keeping it from being sent back to you. That's sort of the future of how all of the data transfer is going to work. Safari is doing that with a referral sandbox, and a similar thing is coming to Chrome. So really, I just want to say thank you for everyone for joining us, spreading the word about this. Obviously, everyone on our team here at MetaX, and we really just want to make sure that any inconsistencies, questions you have, or problems in your deployments, ping us. We will try and help as much as we can in the limited time we have for non-paying clients. But we also anticipate to do a few more of these webinars where we'll update them. So as we learn more about the double cookie solution and maybe some nuance there, we'll drop that. As we sort of get into a little more of the browser API and the state tokens, we'll drop that. But we basically have now weeks or months, and our focus, Nick, mine, Ken, Eddie, the team here at MetaX, we're just looking to audit sites, find the cookies that need flags, and communicate to your vendors that they haven't updated and how they should update. So if any of y'all are really looking for those types of audits, reach out to us. Our dance card is getting pretty full, so please reach out early if you think you may, even if you aren't ready to sign anything, so we can pencil you in and start to talk. And we will basically follow up after this webinar here with the video link, with the deck, and then just basically with an open door policy. So please reach out to us, hello@metax.io. We're on Twitter. You can ping us anywhere. We really appreciate y'all's time and trying to fix this for the community. So.
All right. Thank you.
Thanks, everybody. We'll talk to y'all soon.